These unique solar collectors heat houses in cold and cloudy Finland because they produce thermal energy in the following three modes: from bright sun, from cloudy sky, and a lot of energy at night using this fan. These unique systems will be described later in this video, but first, let's quickly look at this experiment with a traditional solar collector in cloudy weather. This cloudy sky directs approximately 240 watts of solar energy onto the 2 square meters of this traditional solar collector, which is now heating this liquid in its pipes. We see that the solar energy from the cloudy sky heated the liquid to 28 degrees Celsius, while the ambient temperature was 4 degrees, although a clear sky would increase this temperature difference from 24 degrees to almost 200 degrees. Let's assume that this warm liquid will be circulated through a heat pump, and this is a solar collector, this is a heat pump, and this is a pump which creates this circulation of antifreeze liquid. Calculations lead to the conclusion that the temperature will radically decrease from 28 degrees to this level, which is 17 degrees higher than the ambient temperature. This power will be 65 watts, as a result of which the heat pump will only provide 80 watts for heating the house. But 50 square meters of solar collectors will provide this flow of heat into our house, and this is enough to completely heat the house at a 4-degree ambient temperature. We were able to calculate all this thanks to these well-known energy parameters of solar collectors. We also know that the sun gives such a large flux of radiation during sunny hours, but the flux of solar radiation from a cloudy sky is 10 or 20 times less. Such a light sky gives more temperature and power to the heat pump than such a dark sky. I have already said that these systems in Finland do approximately the same during cloudy hours, and they drew this diagram where these arrows show the transfer of thermal energy from these solar collectors to this heat pump. It is important to answer the question of how our system is better than these well-known heat pumps for heating houses. For example, our heat pump is several times cheaper because this very expensive system of extracting heat from the ground is absent. In addition, the electricity consumption of our heat pump is 2 or 3 times less due to several reasons, including the fact that more than half of our energy for heating the house is heat with a temperature above 40 degrees from solar collectors during sunny hours. Let's place our house with an area of 100 square meters in Germany, near this city, Munich, which has such a climate during the 7 months of the heating season. These temperatures determine the heating needs of the house near Munich, and these kilowatt-hours of heat must be produced entirely by solar collectors alone. We saw that this Finnish company usually installed a small area of solar collectors, and this is a big mistake, because the electricity consumption for heating these houses is approximately equal to traditional heat pump heating. That is why we will use a large number of solar collectors, 50 square meters in the case of that 100 square meter house in Munich, and therefore our electricity consumption is approximately 2 times less. Our solar collectors will heat 3 tons of water with a temperature of more than 40 degrees inside similar tanks during sunny weather, and this is the number of sunny days according to those data on Munich climate. Our 50 square meters of solar collectors will produce these kilowatt-hours to heat the water of that tank, and we see that these heating needs of the house in autumn and spring are completely covered by this heat from the hot water of the tank. By these heating needs of 3 winter months will be covered both by that heat pump during cloudy and night hours and by this heat from the tank. Here we see pipes not only for solar collectors antifreeze which heats the cooler tank water during sunny hours, but also other pipes where the home heating system water is heated by the tank water. Let's imagine that the solar collectors heated the tank water to 50 or 60 degrees Celsius during a completely sunny day from this sunrise to this sunset. Here, during operation of the solar collectors, the tank heats the house with maximum power, about 6 kilowatts. But here, after the collectors stop working, the power is reduced to 1.5 kilowatts, so that this concrete receives the required 65 kilowatt-hours of heat during these 24 hours. 15 tons of this concrete smooth out this uneven heating, and therefore the temperature fluctuations of the upper surface of the concrete are less than 3 degrees. This is the next day, which was completely cloudy, and this is the heating by solar collector through the heat pump with a power of 3 kilowatts. These 40 kilowatt-hours of heat come from the tank during the night, so that the concrete receives the same 65 kilowatt-hours during those 24 hours. This is the situation at the beginning of a long cloudy period, when the tank temperature drops to 40 degrees, because it transfers its last energy here, about 15 kilowatt-hours of heat. Therefore, the heat pump must provide these 50 kilowatt-hours, and 70% of this energy is produced here from the sunrise to the sunset. The remaining 30% is produced here after the sunset, and therefore let's analyze what will happen at night if the circulation of the antifreeze continues thanks to the operation of this pump or this small pump with electricity consumption of 10 or 20 watts. This is a traditional solar collector, and this metal surface must be heated by solar radiation and transfers the heat to the antifreeze liquid, which circulates through these pipes. During the night hours, this surface with pipes will act as a heat exchanger, where ambient air transfers thermal energy to the cooler antifreeze. Unfortunately, this glass sheet and other features reduce the heat transfer power by about 5 times, and I have already shown you these energy parameters of solar collectors. Here we see that every degree of temperature difference between the ambient air and the antifreeze increases the heat transfer power by 4 watts for each square meter. Therefore, we can quickly calculate that, for example, if the average antifreeze temperature is 3 degrees less than this ambient temperature at night, our 50 square meters of solar collectors provide 600 watts of thermal energy to the heat pump, which turns them into 800 watts of home heating power. It is important to say that homemade solar collectors are better for the night operation, because this coefficient is almost 2 times greater. The night operation of these finished solar collectors is interesting thanks to this fan. The fan rotation directs the surrounding air into the collector, as a result of which the heat exchange between the antifreeze and the surrounding air is radically improved. This is the situation during a long cloudy period when the heat pump operates 24 hours a day. Here the solar collectors provided with solar energy from cloudy sky, and these are the night hours when 50 square meters of solar collectors take 1 kilowatt of thermal energy from the ambient air, and the heat pump turns it into 1.5 kilowatts. I already showed this data 4 minutes ago, and this is the heating needs of the house near Munich. This is the heat production of our solar collectors during sunny hours, when the heat with a temperature of more than 40 degrees comes into the water of the tank, and then the heat will go into the house without the help of the heat pump. Here it describes the heating of those 3 tons of water in the tank to about 90 degrees at the end of October. Cooling it down to 40 degrees releases this thermal energy, which will hit the house in November, together with this energy from the solar collectors. In addition, the solar collectors will produce this thermal energy during cloudy hours and this energy during night hours. Therefore, from approximately the 10th of November to approximately the 10th of March, this pump operates continuously during the daytime hours, from sunrise to sunset. The switches between this connection of the solar collectors to the heat pump and this connection of the collectors to the pipe inside the tank are made by thermostats. It may be necessary to occasionally turn on the defrost mode to remove ice or snow from the surface of the solar collectors using the heat from the tank, although warmer regions may not have this disadvantage. At the same time, only approximately half of the night hours are accompanied by this heat production, and the remaining half is such or such or such, when the solar collectors do not work at night or work only for a few hours after sunset. I remind you that this thermal energy goes to the heat pump, which consumes this amount of electricity, and this is the heating of the house. We see that these heating needs are fully covered by this heat for each month, and this electricity consumption by the heat pump is about 1300 kilowatt-hours per heating season. These are estimates of the cost of the entire system, and this cost can be several times less in the case of homemade solar collectors. The cost of this heat pump will be less if you also use it to pump the thermal energy from those 3 tons of water, with a decrease in the water temperature from 40 degrees down to 5 degrees. This method reduces the heat pump power requirements, and it will be described in more detail in my future videos, together with different methods of increasing the heat production of solar collectors.